Okay, based on some of the responses I've seen on the powers of 10 uh, assignment, I don't feel I gave a order of magnitude estimates a sufficient treatment. So I'm going to discuss it a little bit here in this video. So this first section here. I'm sharing my Mathematica uh, file with you, and this first uh, section is just right out of your book, section 1.5, estimates and order of magnitude calculations. And I'll just read it. Suppose someone asks you the number of bits of data on a typical Blu-ray disc. In response, it's not generally expected that you would provide the exact number, but rather an estimate, which may be expressed in scientific notation. The estimate may be made even more approximate by expressing it as an order of magnitude, which is a power of 10 determined as follows. Number one, express the number in scientific notation with the multiplier of the power of 10 between 1 and 10 and a unit. Uh, Number two, if the multiplier is less than 3.162, the square root of 10, the order of magnitude of the number is the power of 10 in the scientific notation. If the multiplier is greater than 3.162, the order of magnitude is one larger than the power of 10 in the scientific notation. Let me give you an example. Uh, let's just say, well, how far is it from San Antonio to Dallas? This was when I worked for Texas Instruments way back in the 70s, a long time ago. Uh, the uh, it would typically I would drive back and forth from San Antonio to Dallas quite often because my family was still here in San Antonio, and it would took roughly about 4 hours uh, to get back and forth. Sometimes more, sometimes less, depending on traffic conditions, construction on I-35, uh, those types of things. So the typical drive time from San Antonio to Dallas is roughly about 4 hours. Now let's estimate that the average speed is 100 kilometers per hour or 62 miles an hour. So the very simply, if we're doing it in um, kilometers, let me put a little notation here. I should have probably done this ahead of time. Um, approximate uh, approximate uh, uh, distance in kilo- ah, kilometers. Okay, so it's uh, 4 hours, 4 hours times 100 kilometers an hour, which is 62 miles per hour. So the it's about uh, 400 kilometers roughly. Well, the actual distance um, is I've looked it up. It says 353 miles. So that's close. That's close. But now, how do we express that um, in scientific notation? Well, that would be 4.00 times 10 to the 2. Well, the 4.00 is greater than 3.162. So the instructions in 2 says if it's greater, then you up it. So my uh, order of magnitude would be 10 to the 3. 10 to the 3, which is a thousand. That's the order of magnitude is 10 to the 3. That is the answer. Now let's do it in kilometers. I mean in miles per hour. So if we do 4 hours times 62 miles per hour, we come up with 248. So that the 248 would be 2.48 times 10 to the 2. Well, that's less than the 3.162. So an order of magnitude expressed for miles per hour would be 10 to the 2. 10 to the 2. So we've got two different orders of magnitude, irrespective. I mean, depending on whether you're looking at kilometers or whether you're looking at uh, miles, for the distance. So I've looked, and let me see, 1,000. Um, if I do 1,000 kilometers, that's equivalent to 621 miles. Well, that's about uh, double, a little less than double the 352. If I look at 10 to the 2, 100 miles, uh, 100 miles, express that in kilometers, well, that's 160. So it's a little bit low. One you get a little bit high, one you get a little bit low. But it all works out, especially when you have multiple calculations. So anyway, the on your powers of 10 assignment, you should, when you on that second page where you're getting orders of magnitude calculations, it should only be like a 10 to the 3 or a 10 to the 2 or something like that. I think I give you 3 assignments. And I'm not expecting a number. I'm just expecting the 10 to a particular uh, uh, exponent. Okay. I hope that explains it a little bit better. I'll send this out to y'all.